Welcome back everyone. So this session will be all about remainder theorem and factor theorem in polynomial. Let's get started right away. Remainder theorem. It says when the polynomial function fx is divided by x minus a, the remainder is fa. Now we can write these words into an expression using algorithm of division as fx equal qx times x minus a plus r, and putting x equals a, we would get fa as r. Still confused? Alright, let's see where we can apply this theorem through an example. When the polynomial function x squared plus ax plus b is divided by x minus 1 and x plus 1, the remainders are 2 and 3 respectively. Find a and b. So we know fx equals x squared plus ax plus b. And by remainder theorem, we can write f1 equals 2 and f minus 1 equals 3. So now when we put 1 in fx, we get f1 equals 1 plus a plus b. And further solving, we get 1 equals a plus b. Similarly, when you put 2 in fx, we get 2 equals a minus b. Now solving this simultaneous equation, we get a as minus half and b as 3 by 2. So this is one place where we use remainder theorem. Let us now see what factor theorem is all about. It says the necessary and sufficient condition required for x minus a to be a factor of fx is fa equals 0. In other words, the remainder is 0. Simply, the theorem says if fa equals 0, then x minus a is a factor of fx. The converse of the theorem is if x minus a is a factor of fx, then fa equals 0. Let's see an example. X cubed minus 7x plus 6 divided by x minus 1. Fx equals x cubed minus 7x plus 6. And when you put x equals 1, you get f1 as 0. We can say x minus 1 is a factor of fx by factor theorem. Another example, 2x squared minus 3x minus 4 divided by x plus 1. And when we put x equals minus 1, we get f minus 1 as minus 5. Now, since it's not 0, x plus 1 is not a factor of fx. So generally, the factor theorem is used to factorize polynomials. Let's see an example. Fx equal x cubed plus 2x squared minus x minus 2. We can put x equals 1 in fx, then we get f1 equals 0. Therefore, x minus 1 is a factor. Now put x equals minus 1. Then f minus 1 equals minus 1 plus 2 plus 1 minus 2, which again gives f minus 1 as 0. So therefore, x plus 1 is also a factor. Now you might think how I assume plus 1 and minus 1 and what for x. It's simply by guessing. Let's try x equals minus 2. Then we get f minus 2 as 0. Therefore, x plus 2 is also a factor. Now we can write fx as x cubed plus 2x squared minus x minus 2 equals x minus 1 times x plus 1 times x plus 2.